In tonight's video, we're going to be focusing on the second success criteria for our matter unit, where we're going to be learning how to analyze the different types of matter in terms of structure and organization. And in this particular success criteria, there is a significant amount of vocabulary that we are going to need to remember. The first is the word matter, and we have to remember that there are 4 conditions for matter now. The first is that it has mass. The second is that it has volume. The third is that it's made up of particles. And the last is that those particles are in constant motion. So we can split matter into 2 categories. And the first is pure matter, also known as a substance. Now, pure matter cannot be physically separated. The only way to separate pure matter is to be breaking chemical bonds. Which takes a significant amount of energy. The first type of substance, or pure matter, is an element. An element is the simplest and unique form of matter. Often called the building block of matter. So in chemistry, elements are particularly important. In fact, we have a whole table of them called the periodic table of elements. So for example, we can have hydrogen or sodium or chlorine. All of these are single types of elements, and we quantify them using the word atom. The second type of pure matter or substance is called the compound, and this is when 2 or more different types of elements are chemically bonded together. So for example, we can have sodium chloride or table salt, where it's 1 atom of sodium bonded to 1 atom of chlorine. Or we can have a water molecule, which is 2 atoms of hydrogen chemically bonded to 1 atom of oxygen. So that takes care of the pure matter side. The more complex side is the unpure matter, or what we know as mixtures. And mixtures are incredibly important to know because you will encounter more of those over time than not. So mixtures are ones that can be physically separated. And there are 5 different types. 1, we can use the density of objects, so it'll make layers. 2, we can use a magnet. 3, we can use filtration. The fourth is that we can evaporate a liquid off to get something else, or we can use decantation, which is just a very scientific and fancy word for pouring. So there are two types of mixtures, homogeneous and heterogeneous. A homogeneous mixture is when every sample will be the same. Because it is evenly mixed. And an easy way to remember is that homo means same. The other types of mixture is a heterogeneous, where every sample will be different. Because it's unevenly mixed. And an easy way to remember is that hetero means different. So at this point is where IB stops. But I believe that knowing the subcategories of homogeneous and heterogeneous mixtures will help you be better consumers, better scientists, and overall better people. So a homogeneous mixture is synonymous with the word solution. And a solution is a clear mixture that's not necessarily colorless. So clear and colorless do not mean the same thing. So when we say clear, what we mean is that light will pass through. So some examples include things like honey and Windex. Another example would be like vanilla in your for baking. There are two types of heterogeneous mixtures, colloids and suspensions. Suspensions are really easy to view. They are already layered out. So this is a mixture that has layers. So for example, like oil and water will sit on top of each other because they have different densities. So it is known as a suspension. Another one is cereal and milk. Again, because of the different densities, cereal floats on top of milk. The last mixture is actually pretty difficult to identify. And it's not because it looks different. It's actually because it looks identical to a solution, but with a clear difference. It's actually an unclear mixture that refracts light. And it fails something called the Tyndall effect. Where if we shine a light, like a flashlight, into a colloid, you'll see a distinct beam of light. And we'll explore this in our distinguishing liquid mixtures activity. So some examples of colloids are fog, which is why they make special headlights on vehicles for fog. You don't want to shine normal headlights because all you'll see is the beam of light. Shaving cream due to it being an unclear mixture or an unclear liquid, and milk. So milk is also an unclear liquid, and the particles that make up milk are unevenly mixed. So part of your responsibility in this particular unit is not only knowing the definitions of these particular vocabulary words, but also to be able to categorize and explain how and why all these different types of matter are different, starting with elements and compounds and leading into homogeneous and heterogeneous mixtures.